Hello mga ka-tribes! Welcome to Daddy Brew TV. For today's video, let's have solving irrational inequalities. Now, let's have example number 2. Solve the rational inequality, then graph its solution set. The rational inequality is x over x minus 2 is less than 3 minus 2 over x minus 2. Solution. Take note that the LCD is x minus 2. It implies that x minus 2 is not equal to 0 or x is not equal to 2. Now, let us transpose all the given terms on the left side of the inequality and let the right side equal to 0. And that is now x over x minus 2 plus 2 over x minus 2 minus 3 is less than 0. X over x minus 2 plus 2 over x minus 2 is equal to x plus 2 over x minus 2 minus 3 is less than 0. Now, the LCD is x minus 2. So let's divide x minus 2 to the denominator x minus 2 times x plus 2. And that is now x plus 2. Minus x minus 2 divided by 1 times 3. And that is now 3 times x minus 2 is less than 0. Then let's simplify the numerator. We have x plus 2 bring down minus 3x distributive property plus negative 3 times negative 2 is positive 6 over the denominator x minus 2 is less than 0. Combine similar terms on the numerator. X minus 3x is negative 2x. 2 plus 6 is plus 8. So that is now negative 2x plus 8 all over the denominator x minus 2 is less than 0. Now, the critical values are the numerator negative 2x plus 8 equal to 0. Let's solve for x. That is now negative 2x is equal now to negative 8 by transposing positive 8 to the right, divided both sides by negative 2, and that is now x is equal to 4. And the denominator x minus 2 equated to 0. And solving for x, that is now x equal to 2. These are the critical values. In interval form, that is now equal to from negative infinity to positive 2. From positive 2 to positive 4. And from positive 4 to positive infinity. Now, let's make a table. Okay. Let's choose a value of x from negative infinity to positive 2 from this interval. Let's say 0. If we substitute 0 in the numerator negative 2x plus 8, the result is positive 8. Okay? Now, between 2 and 4, let's try 3. So, if we substitute 3 in the numerator negative 2x plus 8, that is equal to positive 2. And from the interval 4 to positive infinity, let's try 5. If we substitute it in the numerator negative 2x plus 8, that is now equal to negative 2. Next, what about the denominator x minus 2? If x is equal to 0, that is now negative 2. From the interval 2 and 4, if x is 3, that is 3 minus 2 equal to positive 1. From the interval 4 to positive infinity, say 5, if x is 5, that is now 5 minus 2 is positive 3. Next, so therefore, we can now say that if we divide the numerator and the denominator, say 8 or positive 8 divided by negative 2, that is negative 4. The sign, take note, is negative. The sign is negative. Likewise, from the interval 2 and 4, if we divide 2 and positive 1, or positive 2 and positive 1, the result is positive 2. The sign is positive. From the interval 4 to the positive infinity, if we divide negative 2 and positive 3, the result is negative 2/3. The sign is negative. Now, therefore, the solution set now is this area. The interval negative infinity and the interval positive 4 to positive infinity. Or the interval negative infinity up to positive 2 and the interval 4 and positive infinity. Why? Why? As we recall, the arguments is negative 2x plus 8 over x minus 2 is less than 0. Meaning, we will only consider the area or intervals that are less than 0. And that is the negative regions. Right? Same is true for the graph. The graph is from positive 2 to the left up to its negative infinity, and from positive 4 to the right up to positive infinity. Meaning, the solution set now is the union of from negative infinity to positive 2 and the interval positive 4 to positive infinity, or all real numbers except positive 2 up to positive 4. Okay? Bye! Thanks for watching. See you on my next video.